Hello everyone, and in today's video we'll be exploring different ways of creating a matrix and an array, like creating an array from Python's lists. And there are many different ways, inbuilt functions in Numpy which you can use to create a matrix, which will later be beneficial and it will come in handy when we are doing data analysis using or data pre-processing using pandas and matplotlib. So let's get started. Okay, so I have already imported Numpy. Now, the very first thing that we'll see is how we can create a arrays from Python. Now, from the previous videos, if you observe inside this function, what we are putting is a list, right? 10, 2, 3, 4, 5 is a list. So if I write something like this, L1 is equal to creating a normal Python list with elements 5, 6, 7, 8, and 9. And then I write array 1 is equal to dot array, and inside parenthesis now I will not give in this list, but I will specify this variable over here. So I'll write L1 and then we'll print array 1. So what we see is we have received or we have gotten the desired output of an array having 9 elements in it. Now I'll add in one more cell, and if we type array 1 dot shape, we'll see we have 9 elements and 9 comma nothing. That means it is a one-dimensional array. A different way in which we can create arrays is using for loop. Now, let's say I write for I in, let's say I do something like this. L2 is equal to nothing. That means we have created an empty list. And then I say for I in range from 0 to 9. Okay. I want L2 dot append I, fine, and then we will print L2. We get a list. It's the same thing. We are using for loop to create a list, and then we are giving in L2 as a variable, as an input to array, like np.array, and now we will give L2. Let's specify this as array 2 is equal to, and if I print array 2, we get from 0 to 8, because when you are using for loop, if you give in 9, it goes to n minus 1, so from 0 to 8. Okay. Similarly, another way in which you can create a matrix or a numpy array is by writing np.array. Within brackets, we'll write range is from I to I plus 3, and for I in, let's say, a list of 2, 4, and 6. If I print this, we get this array. Now this for loop looks a bit complex. If you don't understand it right away, it's completely fine. Using this for loop also, you can do the same thing. I'll show it one more time using a normal for loop. But for now, let's try to understand what's written over here. So for I in a list having 2, 4, and 6, what we are seeing is go from range I to I plus 3. So for 2, if we have the first element for I when I is equal to 2, we get 2, and then 2 plus 3, that's 5. So the first row we get as from 2 to 5, so 2, 3, and 4 will be printed. Second element is 4, so from 4 to 7, 4, 5, 6, and the third element is 6, so from 6 to 9. So what we will get is 6, 8, 6, 7, and 8. Now writing this thing in a normal for loop, what we say is, let's initialize a variable result of for with an empty list, and then we say for I in list containing 2, 4, and 6, rows is an empty list. Then what we say is for j in range I comma I plus 1, row is row dot append j, and result dot append row. Then we say mat is equal to np dot array with result in that, then print result. Okay, so this will be 3, not 1. 3. We get this. we are printing mat over here, right? Matrix. Yeah, so we are getting a matrix. Simple. So what we have done is we have created an empty list result, and then we are making a nested list using for loop. So for I in 246, what we are saying is let row be empty. So for first row, what it will take 2 as an element, and it will go from 2 to 5, and it will have 2, 3, and 4 in it in the first row. And then what we are saying is that you append that row into result. So result will now be a nested list with one list inside the main list. Similarly, it will loop over 4 and 6, giving us a result. Let's print that also. Print a result. So we get this result. This is a nested list, and then we are using this nested list, giving it in the in np.array function to get a desired matrix of 3 cross 3 using for loop. Moving on, let's see what different ways we have to create an array or matrix. Now, matrix with only zeros. There is a function called np.zeros. Okay, np.zeros with an s. You have to specify s over here. Now, inside parenthesis, when you are specifying the dimension, we have to add another parenthesis in that. Let's say we want a matrix 3 cross 3. So 3 comma, we print it over here. Now the result we got is 0 point something. So by default, np.zeros or any functions, inbuilt functions using in Numpy creates a integer base, an integer type, a float type matrix. So what we do is we add comma and write d type. Let's say we want an integer, so we write d type equals to. Then we print it, so we receive an integer type. We get an integer type. Now matrix with only ones. Similarly, same thing, instead of zeros we'll have ones with an s. Ones inside parenthesis, again parenthesis, there's a 3 cross 3 matrix with d type of int. We get matrix filled with 1. Now matrix filled with one element. Let's say we want a matrix to be filled with one element, but I don't want zeros and 1, I want something else. Now you don't have any function called np.threes or fours like that. What you can do is you can use a function np.full. Again, same process, 3 comma 3 with a d type of data type of. You have to specify what numbers I want. So over here, before d type, I have to specify which number I want. Let's say 10. So I get 10 over here, and the data type remains integer. So I want to change. Let's say I want np.full. This time 5 comma 8, let's say, and I want 3.14. Okay, even if I don't give a data type, it will create a matrix of data type float using arrange and linspace. Now, what is arrange? I have used arrange in my previous videos. Let's see what arrange can do. If I say np.arrange and I write 20, I get an one-dimensional array, okay, of elements having consisting elements of 0 to 19, means from 0 to 20, any elements between 0 to 20. And now let's say I want to skip some elements. I want 0, but I don't want 1, I want 2. I don't want 3, but I want 4. I want to skip one element. So I write mp.arrange, and inside this, if I given 0 to 20, skipping 2. Okay. Now this time we have to mention 0 to 20. We have to mention this 0. Giving 20 will give us a different result. We'll explore that also. We'll get 0, 2, 4, 6, 8, 10. That means anything that is divisible by 2. What if I write np.arrange and 20 to 2? What do we get? We get an empty array of data type int 30. Why is that? Because 20, from 20 it can't go back to 2. Arrange always needs something, first element to be smaller than the second element. So if I write this, we'll get our result. Okay. Now using linspace, what linspace does is it linearly spaces out and creates an array spacing out the elements. For example, np.lin space, if I given from 0 to 1 and I want 5 elements. What it does, it creates 5 elements from 0 to 1 that are equally spaced. Let's say I want np dot space from 0 to 10, and I want some 7 numbers. So it will create 7 numbers, 7 elements from ranging from 0 to 10, which are equally spaced. Using random. Random is a function which generates a random number. So if I write np.random dot random, np.random dot random, and I say 10, what it does is it creates 10 element randomly. Okay, from 0, between 0 and 1, if I don't specify anything, it creates 10 element randomly. Let's say we specify a 3 cross 3. Okay, np dot random dot random. I want a 3 cross 3 of 10. Okay, so this won't work. Let's create a 3 cross 3 matrix. What it does is from 0 to 1, it creates random numbers and arranges it into a 3 cross 3 matrix. Okay, moving on. What I want to create is a matrix which is normally distributed. So np.random.normal, and inside brackets, what I'll specify is 0, 1, comma. I want from 0 to 1, and let's say I say 3 cross 3. Okay, so we get 3 cross 3 matrix which is normally distributed. Now, identity matrix. What is an identity matrix? Identity matrix is a matrix where the diagonals are 1. So there is a function np.I, and within which we specify the dimension. We get a 3 cross 3 matrix of this. Let's say I don't want 3 cross. Now, identity matrix are always squared matrix. So you don't always have to input. Inputting this, using this will not give you a result, because identity matrix by default are square matrices. So you have to give in one value. Let's say 5. It will create a square matrix of dimension 5 cross 5, which has diagonals 1. Yes, you can specify data type as it will create integer data type matrix. That's all for today's video. Thank you for watching.